Hi, my name is Ion Green, and this is how to identify what acid-base reaction is occurring. This is from Chapter 12, Problem number 6, which can be found on page 157 of the ACS Study Guide. This concept comes from General Chemistry Part 2. So after reading the question and identifying what is important, what are we trying to find, and after reading our answer choices, it's important to make sure that you understand the answer choices, make sure that you know what the answer choices are talking about, because sometimes questions like to play little tricks on you where it could be close to being the answer, but not exactly correct. Okay, so what I like to do, starting off with the Arrhenius acid and base. In class we learned that the Arrhenius acid and base is this. So we can identify Arrhenius acid and base by an acid having a positive hydrogen producer, or a OH negative producer, or a base being an OH negative producer. And in an equation, or for an example, this is what it may look like in a reaction. So after looking at our equation here, you can clearly see that there is no OH negative or any hydrogen or a positive hydrogen. There's not both inside of our reaction. So yes, we'll cross out our Arrhenius acid base as an option. Next, we'll be doing our oxidation and reduction. In class, we learned that oxidation is loss and reduction is gain. Here's a little example of what to expect when you see that. And we also learn, like in high school chemistry, that electrons are negative, protons are positive, and neutrons are neutral, and all that fancy stuff. So it's important to keep that in mind when looking at our equation, especially its charges. So I've rewritten the equation here on this index card. Alright, so I'm going to circle all of our electrons so that we know whether they're positive, negative, neutral, all of the above. So after looking at these, this one here, this +2, is outside of the parentheses, which means that it goes for both molecules, inside of the parentheses. And after looking at it, keeping in mind that oxidation is loss, reduction is gain, okay, and that electrons are supposed to be negative, you can tell that copper here, it loses 2 electrons. So it looks like -2 electrons, and not forgetting that electrons are negative. And then let's see over here, it gains 2. Sorry, messed up there a little bit. It's gaining 2. Forgot that they were positive for a minute. But it's gaining 2 electrons. You go like this, it's 2 plus 2, it will equal 0. The negative comes from a negative electron. Okay, yes, there we go. Okay, so here, it's losing 2 electrons. The loss of 2 electrons means that oxidation is happening. So oxidation. And then over here, gaining 2 electrons means that reduction is occurring. However, notice that on both sides, 2 electrons are either being lost or gained, which means that the reaction is balanced because you're losing 2 and gaining 2 at the same time. So because of that, oxidation, answer choice C, is not correct. It would not be our answer. Okay, next one to look at is Bronsted-Lowry acid and base. Okay, so Bronsted-Lowry says an acid is a proton, which is hydrogen positive, donor, and our base is a proton acceptor. Okay, so for me, I like to determine the flow of protons, electrons, and everything by writing it out like this. Sorry. Okay. So, here, there's only one of these, and there's copper, there's only one copper. Nitrogen, there's 4 nitrogens, and then 4 times 3 is 12, so there's 12 hydrogens. Over here, there's still 1. There's 4 times 1 is 4, then 4 times 3 is 12. So there's 12. Looking here at hydrogens on both sides, they're both equal to 12. There's 12 hydrogens on both sides, which means that this reaction is a balanced reaction, meaning that sadly Bronsted-Lowry is not our answer either, leaving only B, which is Lewis acid and base, to be our answer.